Welcome to Aqua Platecodon, where more useless knowledge gets unlocked. Before we begin, we have a confession to make. After hours of research, deep analysis, and exhausting every possible explanation, we still don't fully understand how quantum computing actually works. And if you think you do, you might have been tricked. But here's the thing. Nobody really understands quantum mechanics. Even the world's top scientists admit that quantum behavior is weird, unpredictable, and completely different from anything we're used to. Richard Feynman, one of the greatest physicists of all time, once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." So if this entire field turns out to be one giant overhyped tech bubble, remember, blame Google, IBM, and the research labs that poured billions into it. Not us. We're just the messengers. We're the good kids in this story. But assuming quantum computing is real, and not just a sci-fi dream, let's break it down in a way that actually makes sense. Imagine you're trying to find the shortest path through a massive maze. A classical computer works like a person walking through the maze step by step, testing one route at a time. But a quantum computer? It's like it sends infinite versions of itself down every path simultaneously, instantly finding the best route. This is because quantum computers don't think in simple zeros and ones like classical computers. Instead, they use qubits, which can be in multiple states at once thanks to a concept called superposition. They can also be entangled, meaning one qubit instantly affects another, even if they're light years apart. If that sounds weird, congratulations. You now understand why nobody truly gets quantum mechanics. But what does this actually mean for the real world? Let's look at 3 areas where quantum computing could change everything. One of the biggest challenges in medicine is simulating molecular interactions. Right now, even the most powerful classical computers struggle to predict how new drugs will interact with human biology. It takes years of trial and error, billions of dollars, and a lot of failures. Quantum computers, however, can simulate molecular interactions at the atomic level, something classical computers just can't do efficiently. If this works as expected, it could lead to faster drug discovery, more personalized medicine, and even cures for diseases that currently have no treatment. Now here's where things get interesting. Quantum computing could break most of today's encryption systems. Right now, internet security relies on encryption methods like RSA and ECC, which work because classical computers can't quickly factor large numbers. But quantum computers? They can crack these codes in minutes. That means banking systems, private communications, and national security could all be at risk. But it's not all bad news. Quantum mechanics also allows for unbreakable encryption through something called quantum key distribution, QKD. This means that while quantum computers could destroy today's cybersecurity, they could also create a whole new level of security that's impossible to hack. AI and machine learning deal with huge amounts of data and complex optimization problems. Classical computers struggle when handling extremely high-dimensional datasets, which makes training advanced AI models slow and expensive. Quantum computing could massively accelerate AI development by solving problems that classical computers simply can't. If this becomes practical, we could see AI models that train in minutes instead of days, and algorithms that can analyze massive datasets in real time. This could lead to entirely new forms of intelligence, or just more AI-generated cat videos. This all sounds exciting, but there's a catch. Quantum computing is still in its early stages. Right now, most quantum computers only work under extreme conditions, like temperatures close to absolute zero, and they struggle with error rates and stability issues. In short, we're not getting quantum-powered smartphones anytime soon. But the research is moving fast, and if companies like Google, IBM, and startups working in this space can crack the stability problem, quantum computing won't just improve existing technology, it will change the world. So if this turns out to be the next tech revolution, you heard it here first. And if it turns out to be one massive failure, remember, we already told you to blame the big companies. That's all for today. See you in the next one.